Hi everyone, in this video we are going to discuss hydrogen as a source of fuel. So specifically what I want you to be keeping in the back of your mind is how we could use hydrogen as a source of fuel in a fuel cell. So let's recall, fuel cell is an electrochemical cell that converts chemical energy to electrical energy, but it has to have a constant supply of fuel. And so hydrogen is a beautiful, beautiful source of fuel for a fuel cell, especially if we're talking about a PEM or a proton exchange membrane fuel cell, okay? It's a lot of information, but we have to keep it straight. But this video, we're just going to focus on the hydrogen aspect of it, or the hydrogen as a fuel source for that, okay? All right, so what we're going to start off with is some just basic information about hydrogen gas. First things first, it is a gas, okay? As a gas, it occupies 11 liters per every gram of gas. So that is a lot of space. 11 liters is a huge amount of space for a gas to occupy if we're just talking about 1 gram. Okay, it occupies a lot of space. Get that through your brain. All right, next. We know that hydrogen has a lot or a high potential energy stored within the bonds. Okay, so this is within that hydrogen-hydrogen single bond. And so now we have already said in previous videos that it is about 124.5 kilojoules of energy that can be released upon the combustion of 1 gram of hydrogen, okay? That's insane. Remember that up until this point, the greatest source of fuel we've been talking about is methane, and that releases only 50 kilojoules of energy per gram burned. So hydrogen is a beautiful, magnificent source of fuel, but it is unbelievably explosive. And so we have this huge issue that we need to overcome, which would be storage and transportation. And so one of the things that we've been able to come up with, I say we, but I had nothing to do with this, obviously, transportation, is that we were able to come up with something called metal hydride storage system. So what that means is we basically create a very, very large pressurized H2 tank. And inside the tank, we have what's called this metal hydride system. And so we pump the tank full of the metal hydrides, and then after that, that's when we try to add the hydrogen gas, which seems counterproductive in our mind, but it actually works really, really well. So let me see if I can pull up a picture of this to kind of help you with this. So let's start off on the left side. So usually what we do is we have what's called hydrogen gas, right? And we add our hydrogen gas into our cylinder. But what we need to understand is in here, there are a lot of metal hydrides, and a very common one would be lithium hydride, right? And so this is a very, very common metal hydride, and what it does is it's unbelievably selective. So when you pump gases in there, the only ones that lithium hydride are going to absorb, okay, so they're going to pull it into its system and grab it to it, and basically pull the gas out of the air and grab it to its solid state, is going to be hydrogen gas. So regardless of the purity that you send into the tank, these metal hydrides are selective. So they're only going to uptake hydrogen gas. So if somehow carbon dioxide or maybe carbon monoxide got in there, the lithium hydride would just let that float right on by. It wouldn't want to touch it. But as soon as the hydrogen comes by, it reaches out and grabs it. So every single hydrogen it pulls in. It's selective, okay? So let's start putting some of this information down in writing. So these metal hydrides are selective. That's the most important thing. That's the reason why we have it. Now, that means they only absorb hydrogen over other gases. The second thing is that with these tanks is we can just control the temperature to make something happen with the pressure. So if we increase the temperature, that means we're going to increase the pressure. So that means we're going to be able to charge the tank or create or force more hydrogen into the tank, okay? The opposite would be if we decrease the temperature, we would want to decrease the pressure. So this would be discharging. So what that means is if we decrease the temperature of the tank, the pressure is instantaneously going to go down. And so what happens is the pressure is usually released. And so it gives off the hydrogen gas. So just by messing with the temperature of the tank, we can control whether or not the hydrogen is coming in and out of the tank, which is really, really cool. Just by changing the temperature, we can force this tank to either spit out hydrogen or take more hydrogen in, which I think is just really, really neat. All right, so that's our storage piece. That's what we talked about. Now, the second thing we want to talk about for hydrogen, and that's the big one, is that there's a really, really big demand for hydrogen gas. Okay, especially as a fuel source. Okay, especially or specifically, I want to say, as a fuel source. So now, here's the thing that is really usually quite perplexing for people, is that hydrogen is the most abundant element okay, in the universe. So approximately 93% of all atoms are hydrogen. That's in the universe. That's everything. That is not just planet Earth. But we're just saying that hydrogen atoms exist. We're not just saying that it's H2 sitting around or it's H3 or anything crazy like that. We're saying that hydrogen atoms, 93% are hydrogen atoms. The problem is most of these hydrogen atoms are tied up in water. So most H atoms are in water. Water, as you know, is incredibly stable, okay? You've had a glass of water before. You've probably gone swimming in water before. It does not instantly explode. It doesn't spit out energy at you. It just sits there and acts like a glass of water that's very, very boring. It's stable, 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 okay? So what we have to do is figure out how do we actually get this hydrogen out? How do we produce hydrogen? What is our reactant in order for us to create more hydrogen if most of our hydrogen here in this planet on Earth is tied up in water? We need to break molecules apart. That's the bottom line. So you have three options, or I should say these are the three common options. The first one is when we have methane. Okay, so you take methane, you treat it with water by adding 2 water molecules, and you create 4 diatomic hydrogens and carbon dioxide. Okay, that's your first one. Your second one, the second piece that happens, is you have what is called carbon dioxide. Whoops, my pen stopped working. There we go. Carbon dioxide. You can treat that with methane, and if you do that, you release 2 hydrogen molecules and 2 carbon monoxide molecules. The last one, which is the one people want to use most commonly, is if you use water by itself, so pure pure water, okay, the molecule water. You can break it apart into hydrogen gas and half of an oxygen molecule. So now, every single one of these processes are endothermic. You have to put energy in. They are not going to spontaneously just create hydrogen gas. So for methane, we have to put in about 165 kilojoules of energy. For carbon dioxide, we have to put in about 247 kilojoules of energy. And this is when we're doing carbon dioxide plus methane. Okay, it's that specific transition. And for water by itself, you have to input about 249 kilojoules of energy in order to decompose water. So now these are our 3 main systems. So my question to you is, which method produces the fewest, let's say, greenhouse gas emissions? And go ahead and use A, B, or C. Okay, which one? Fewest greenhouse gas. Go. All right, did you get an answer? Hopefully you did. All you had to do was look back at these equations and look at the product side. So what is over here? What I see instantly is that A produces carbon dioxide. We know carbon dioxide contributes to global warming, so that's not a good one. For B, it produces carbon monoxide. Carbon monoxide is the silent killer. If we breathe it in, it kills us. We don't want that, right? C is definitely the best option. It just creates hydrogen gas, which is the fuel source. That's what we want. And oxygen, which is what humans breathe. It is completely fine for us to create oxygen for us. All right, C is definitely the correct answer. Hopefully you understand why hydrogen is such an amazing source of fuel, but there are a lot of challenges with it because it is explosive and it's incredibly hard to store and transfer, okay? Have a great week. Take care of yourself and drink water.